Welcome to our group project. In today's pre, we will talk two parts of prediction. The first one is stock index. The second one is the unemployment rate. And in my turn, I gotta talk about stock analyzed with ARIMA and Gauge method. With using the first order absolute change on SP500 and log difference on STI. After checking the stationarity and ACF, by looking at the property of ACF and PACF on squared residue, we decided to use the Gauge 11. The result shows that all coefficient is significant and there is no autocorrelation both on the standardized residue and the square term. By selecting the best performance on window length and distribution on validation set, we get following result on the test set. And the same way for the STI index, we first fit to ARIMA model, and based on the performance of AIC on the residue, we finally choose the ARMA 3.2. For dealing with the arch effect, we finally select the ARMA 1.0 and Gauge 3.1 model to do the validation part. And again, choose the best performance. And here the result of the test set is shown. And let's welcome my teammates to introduce the VAR part on stock index.
Nextly, I will introduce our attempt using VAR. It contains more information than one index models, although facing some challenges. Here's the process. We firstly choose to model three indexes together. Then we process data and find some feedback features. By selecting with AIC, we use VAR9 model, in which the procedures showed white noise features. Finally, by adding data of validation period to re-estimate parameters, we obtained our prediction results. And the model is shown as above. Comparing with results of Sijisheng, we finally used a ARIMA model for STI predicting. And nextly, Rulan will present two better attempts by introducing some other vectors in VAR.
Next, I will show the results of adding bond yields to the stock index using the VAR model and the RBF neural network. First, we look at the SP500 and 10-year US bond yield. After analyzing the data with R, we can find that the log difference processing gives stationary data. For data up to June, we construct a VAR model for training, then select the best parameters using the data from June to August. The best parameter is 8. The forecast image for June to August is also shown in the figure. Then we can get the monthly MAP. Besides, we want to try to solve the problem with a simple neural network, and here we choose RBF. We achieve this through MATLAB. Use the data before June as the training set for modeling. The forecast results for June to August are shown in the figure. Next, we use the same method to predict FE100. Make the same log difference, then get the prediction results of the VAR model. Similarly, get the monthly MAP. Finally, we use the RBF method. We can find that the RBF method can predict the data simply and directly, but the prediction is not so good for the data far away from the training set. Comparing with the results of Sijisheng and Xu Leyao, the conclusion is that we use the ARIMA model for STI prediction, VAR model for the US and the UK prediction.
Hello, I will introduce the unemployment rate prediction part. First, I will introduce the RMAX model. This is the time series analysis that US unemployment rate plot and ACF plot and ADF test, and we can see that US unemployment rate is stationary, but the UK unemployment rate is non-stationary. For the RMAX model is ARIMA plus exogenous variable. There I choose CPI and leading economic index as my exogenous variables. This is the prediction model and this is the prediction result. For June to August, the predict MAP is 26.8%. For UK, from June to August, the MAP is 5.9%. The reason that US is deviation is much larger than the UK because of the US unemployment has a spike when the epidemic began. This is all my part. Thank you.
For VAR model, we choose the Consumer Confidence Index, long-term interest, and CPI for prediction. First of all, let's look at the seasonality of the time series of US and the UK. The first-order differences of US data are stationary, and the second-order differences of UK data are stationary. Let's look at the CSAM plot of US data, which shows significant autocorrelations and cross-correlations. Then we use VAR4 model to fit the data. The simplified VAR4 model is shown below. The test of residues implies the model is adequate. The MAP of the prediction of US unemployment rate is about 25%. Then let's look at the CSAM plot, which also shows significant autocorrelations and cross-correlations. The VR4 model is shown below. Then we test the residues, which also implies that the model is adequate. The MAP of the prediction of UK unemployment rate is about 4.74%. Comparing the prediction results of the two models, the VR model is slightly better than the ARIMA-X, but the accuracy of the prediction of the US unemployment rate is not good for both, which may be due to the huge changes of the US unemployment rate at the beginning of the epidemic. Thank you for your attention.